welcome to all. Today we are going to study about a different unit which is talks about brake system design. Before going to design and analysis of brakes aspect, I would like to show some videos how brake functions, and also I would like to show brake samples where I can describe about what are the components are present in the brake system. Not only that, and also I will show the different types of brake systems that are available in automobile application. I can show the first how car brakes works. This is taken from YouTube video. You can see this is the entire brake things. One is on your left side, you can see the disc brake system. On the right side, you will see the drum brake system. There are two types are available, and this is a brake pedal where you are going to give a mechanical force. With that, it will amplify, right, using the booster. Then this is called master cylinder. You can see that, yeah. Then this is a boost, even smaller movement, it will boost the pressure aspect. Then it goes to the brake fluid activate, and the pistons moves and the brake fluid flow through the brake fluid structure. So the pressurized fluid will reaches to the both disc brake as well as drum brake system. And this is the disc, okay, this is the caliper, this is the arrangement, you can see that. So as the fluid enter, we try to push the piston to make the contact. Once make the contact, they have self adjusting. So another pad also will make a contact and apply a force to stop the disc. This is how the disc brake works. And if you look at the drum brake system, this is called wheel cylinder. Okay, the brake fluid will goes and apply through piston both ways, and such way that, okay, the force will apply onto the braking shoe. This is called the brake shoe, which will make a contact along the rotating drum, okay, and stop the vehicle. So this is how the disc as well as drum brakes works. And in fact, you can see the difference between regular brake system and ABS brake system. Okay, ABS, you know, it's a mostly preferred
the
one.
Hydraulic control unit or modulator of the anti-lock braking system. The ABS control module or ECU sends commands in the form of electrical signals to the hydraulic control unit. This unit executes them using 3 solenoid valves connected in series with the master cylinder and the brake circuits. One valve for each front wheel hydraulic circuit and one for both of the rear wheels hydraulic circuit. This is a simplified diagram of one solenoid valve operating on just one wheel. In normal, non-ABS braking, brake pedal force is transmitted to the master cylinder, then through the solenoid valve to the brake unit at the wheel. The signals from the wheel speed sensor show no tendency for the wheel to lock up, so the ECU is not sending any control current to the solenoid coil.
So until then it acts as a regular brake system.
The solenoid valve is not energized.
The moment
and
activate
hydraulic pressure
EMU,
from the master cylinder is supplied to the brake unit at the wheel. When the control unit detects any lock-up tendency, perhaps from too rapid wheel deceleration, it sends a command current to the solenoid coil. This causes the armature and valve to move upward and isolate the brake circuit from the master cylinder. That keeps the pressure between the solenoid and the brake circuit constant, whether or not the master cylinder hydraulic pressure rises. If the sensors signal continuing excessive wheel deceleration, the control module sends a larger current to the solenoid valve. This lowers the braking pressure by moving the armature up further, opening a passage from the brake circuit to an accumulator, a temporary reservoir for any brake fluid that flows out of the wheel brake cylinders because of the fall in pressure. A return pump sends this brake fluid back to the master cylinder. If the sensors then signal the lower pressure has let the wheel speed up, the ECU stops all command current, which de-energizes the solenoid valve. The pressure rises and the wheel is again slowed down. No matter the phase of operation, pressure in the circuit can never rise above master cylinder pressure.
So this is the way the ABS brake system works. And apart from drum and disc brake, you have other two types. Maybe I can show the first is dual servo drum brake system.
Drum brake system. In drum brakes, the wheel cylinder, with the aid of hydraulic pressure, forces brake shoes out against the drum to create friction and slow the vehicle. The main components of drum brakes are brake shoes, the friction that contacts the brake drum; brake drum, the round cast iron housing that's used to stop the vehicle with the brake shoes; wheel cylinder, the component that forces the brake shoes out to the drums; return springs, springs used to retract the brake shoes; and the self-adjusting system, which automatically readjusts the distance the brake shoes need to travel to contact the drums as brake shoes wear down. When the pedal is pressed, pressurized brake fluid at the wheel cylinder actuates pistons to force brake shoes out against the brake drum. When the pedal is released, return springs pull the brake shoes away from the drums and push the cylinder pistons back into their bores. Drum brakes are also self-actuating. As the brake shoes wear down, they must travel a greater distance to reach the drum. When that distance reaches a certain point, a self-actuating mechanism automatically reacts by adjusting the resting point of the shoes so that they are closer to the drum.
Thus you can see that this is a self dual servo thing. There is one more when you have a heavy vehicles where you talk about the trucks, buses, where you need to have an air brake system. There you need to have a smooth transition. So instead of you have a wheel cylinder, you have a S-cam type. So when the brake fluid approaches here, the cam will rotate equally on the both sides. You can see that. Okay. This is a normal one. Okay. And the moment you apply a brake, you can see that what is happening here. Yeah. So you have equal forces, right? You can have equal forces so that it will be more stable, and not only that, the wear rate between the two brake shoes will be linear. Okay. So those are the videos taken. Now we will show the what do you call it, the samples now, which are already there. Nothing but your drum brake system, right? This is drum brake system. This is the backing plate, you can see, and this is called wheel cylinder. Okay, maybe I can show. This is both are wheel cylinder. In fact, this arrangement is called leading brake shoe. We will discuss what you mean by leading, and generally you will have a leading and trailing, but since you have a two cylinders, that means given force, right, both will activate. Whereas earlier, if you have one cylinder alone, one shoe will be used for the same direction of rotation, other will be opposite direction. If you have another cylinder, right, both will have a same direction of the disc, so it will be much easier to stop the vehicle. That's the reason to have a leading shoe brake system. You can see that, and this is will have a piston again inside. The fluid will go through. You can see that how the fluid goes inside, right? And this is for a bleeding. bleeding means suppose the brake fluid traps with the air, you have to release the air, otherwise you will have a problem. So that can be eliminated using this bleeding thing. And interestingly, you can look at here, this is your friction material or brake line material. This is the one which create friction, converting all kinetic energy, right, into friction energy. This is what happens. This is the very important interface between your brake with respect to rotating wheel. You can see the both ways. Yeah. Similarly, I want to show the other one. Okay. This is a casting plate. If you remove it, it will come off easily. It's heavy though. This just to place it on the thing. Right. You could see here. Again, could you please tell me what is it? It's a drum brake system. Is a leading trailing or leading? It's a leading because you could see the two wheel cylinders are there. Right. And again, back is the backing plate will be there. And you can see this is the spring for retaining aspect. Maybe I could see here. Yeah, these are the springs for retract. Once you release the brake, right, it should come back to the original position. Whereas that one can be arranged, another one self-adjusting. That is the one is called the duo brake system. Okay. Again, you could see this is a friction lining, very hard material to create the friction between the two rubbing surfaces. So far we discussed about the drum brakes aspect. Now you could see the another one, which is a much preferred one, your disc brake system. Right, this is the rotor, will rotate very freely, right, this is the rotor, and this is called caliper. The caliper will have a similar to the wheel cylinder arrangement, right. The only difference is will have one piston, whereas wheel cylinder will have two piston. The brake fluid will go and try to move the piston both ways, whereas this is the only way. Since the caliper has a self adjusting mechanism, other side of the pad also will come automatically and make a contact at the same time to stop the rotor. So this is the typical preferred disc brake system. Maybe I could see that. Yeah, you can see that. Okay. I think, and these are the different types of friction material. You can see that these are the different type of friction material used for the, again you can see that very hard composite material for a friction aspect. I think we will go back to lecture now. Right. Topics to be covered: introduction, brake types, brake working method, design and analysis of different types of brakes aspects, and we will understand more importantly dynamics, which is very important for any automobile or any vehicle brake system aspect. This is the one will indicate about the size of the vehicle, right, that's information. And also we will discuss thermal aspects of vehicle braking and design of brakes for application passenger car. That's the one we are going to focus more in this unit. Already we have seen the videos and also seen the samples. Okay, in today's lecture the learning outcome will understand the basics of brake system, which we have already seen that. So let me ask few questions. So what is the friction? Whether friction is good or bad? Where friction is useful, right? Friction is nothing but to resist the motion, right? That's a basic information about friction. Okay, whether it is good or bad, again depends on the what application, right. In general, friction will tend to reduce the performance, in turn reduce the overall efficiency in general. Any starting from your bearings or your engine parts, gears, right, cam and valve tappets, right, crankshafts, wherever you have relative motion, right, there they would reduce the performance due to the friction. However, it is also useful where you want to use the clutch, right. Clutch means you want to hold it. Okay, when you want to hold it, if a high friction is easy to hold it. Similarly, brakes. So there the friction is very essential. So very useful though. Okay, so that's how I am saying is very useful. And this is a typical automotive brake system. You can see this is taken from Ferrari sports car. Ferrari sports car run maybe around 200 to 250 or 300 kilometer per hour. What would be the braking time? Typical, what will be the braking time? Is in seconds or seconds, right? Will be a second and a half, 1.5 seconds. That's the time you need to stop the vehicle. Such a very high precision, and you can see this nice glowing, right? Yeah, this is glowing happening when you press brake. In fact, this is a disc brake system, and you can see the caliper also. When you apply, the so much heat energy is dissipated through friction. Yeah, that's what you could see here. And yeah, so provides a means of using friction to either to slow, stop or hold the wheels of vehicle. That's an important thing. When car is moving, it has energy stored in the form of inertia, kinetic energy. To stop the vehicle, the brakes convert kinetic energy into heat energy. That is what is happening. So very importantly, it must be high reliability, because if the brake is not working, it's going to be have a fatality, right. So that makes the brakes has to go legal aspect also. It has to go to follow the regulations. Each country will have a brake regulation that must be adhered whoever designed the brake. So which is very critical for a reliability aspect. Yeah, the braking system, you can see the various type of braking system given. So you could see the service brake, continuous service brake, parking brake. Okay. So within the continuous service brake, you can have an engine brake system or retarded type system. Within the engine brake, you will have exhaust valve systems and turbo systems, and retarded aerodynamic, electromagnetic, primary, secondary, inline, outline, all those things are there. Okay. So our concern is we would focus the under continuous brake system, the engine thing we are going to focus. This is what we are going to learn from engine brake aspects. Yeah, let me give information. What does it mean continuous service brake? A continuous service brake is a supplementary braking system capable of producing and maintaining the braking force over a long period without any noticeable wear. The continuous service brake must be therefore function reliably regardless of the condition and effectiveness of other braking system. So now we will understand what is the mean the continuous service brake. The one which is going to be there permanently forever whenever you want to stop or slow down the vehicle. Okay. Whereas the service brakes brake act as on all wheels, the continuous service brake only on the wheels which are connected to the drive aspect. So what have you seen, right? The continuous service brakes must be connected with the wheel drive. Okay. So then that is called a continuous service brake. Let me ask question. You might have seen the long cargo type trailer. When I say trailer, is another name called lorry, right? They might be having how many wheels? At least more than 4 wheels, right? They may have 12 wheels or 18 wheels, depends on the application. So question is, would you expect brakes in all the wheels? Do you think that's viable? Yeah, just think about that. Okay, so wherever your power system is there, you have a brake system which is continuous brake system. Wherever you want important thing only for certain aspect without connecting to the power, there you need to have a service brake system. Okay, so typical brake system will consist of energy source from where you want to generate the power, a play system, energy transmission system, and wheel or foundation brakes. You could see this is the nice braking system. Okay, and this is the drum brake, usually fixed in the rear wheel, and disc brake are at the front axles. You could see that front axle will have a disc brake system, which is traditional way of doing, whereas rear will have a drum brake system. Now that is the system used to be followed, now not necessary. Even the rear wheel also can have a disc brake system. Okay, let me ask question, which is a preferred one? Why the drum brake generally prefer to have a rear brake system, whereas disc brake system at the front axle? What is the reason behind? That's to think about that. Okay, another question, when a brake is applied, how the energy is distributed? Would you think the more braking energy go for a rear axle system or front brake system? So question is, the energy whether is higher or will be equally divided. Okay, that's you thought about it. Let me give one more example. You are moving a car, you are applying the brake. The moment you apply a brake, what is the motion you observe? Will you tend to move forward or will you tend to move backward? Forward, right? So when you tend to forward, because of that is the direction where the vehicle is moving, right? So what happened when you move forward? Why it is moving forward? When you move forward, what happened to the weight of the vehicle? Do you think that entire vehicle will be stay there or will it transfer to the front? So there you have to, because of that you have to take care of your brake energy also. You have to distribute accordingly. That we are going to discuss while designing aspects. And this is, you can see that, and again the typical brake system with the ABS. The only difference is between the regular brake system and the ABS. ABS is a microprocessor controller. ABS is a microprocessor controller, whereas regular brake system is a manual where the driver, the maneuvering of the driver comes into picture. Okay. Have you observed how when you apply the brake, what happened to the wheel? What is the motion of the wheel? What is the motion of the wheel? Is it rolling or sliding or roll slide? What is exactly happening? Right. Please understand, which has the more friction? Is the rolling friction or sliding friction? Sliding has the more friction, whereas rolling is a less friction. That is there, right? That is there. Okay. So maybe I can show you the mu rolling. You can say that this is, I will say mu is nothing but a coefficient of friction rolling, and is just sliding. I will put sliding things. Okay. So as you are aware of this, my rolling friction always lesser than the sliding friction, that is there. Okay. So the moment you apply a brake, what do you expect the normal vehicle? The wheel, rotation of the wheel will stop and start to slide. Right, we need to have high friction because rolling friction is low. So obviously if you see the response, this is a time, just make it as a time in seconds. Of course we are talking in seconds, not in the minutes. And this is your friction. Okay, this is your coefficient of friction. So what happened? It goes like this and stop. This is a regular brake system. Okay, it's a regular brake system, right? How about ABS? Remember in the video it's clearly mentioned the pulse is given in the regular time period interval, right? Pulse is given. What does it mean? If the wheel is rotating, the moment I apply a brake, it sliding, right? At that time, right, again release the brake. If they release the brake, what do you expect? Start rolling, right? Start rolling. Again apply a brake, then it will go to sliding. So when you give the pulses, it goes rolling and sliding and rolling and sliding. By doing that, what is that you are going to achieve? By doing that, you have a control of your vehicle. That is a more safe, more reliable, rather than allowing the entire vehicle to slide. In fact, so if you look at this, the same response, right. If you look at this, it goes follow same thing. After that, it moves like this. So the high friction is what? It's a sliding friction, right? High friction is sliding friction, mu s, right? This is the mu s, and this is your rolling friction, mu r. So you are creating a, it's called stick slip phenomena. Have you heard about stick slip phenomena? Stick means stick together, slip means slide, stick and slide, stick and slide. That's why this is phenomenon called stick slip phenomena. This is the concept is applied in ABS brake system. Okay, now you know the difference between a regular brake system and ABS brake system. Okay, so the friction has to be lowered down, right, so that you will have better control. Yeah, type of energy source. So energy source, how does the energy comes to the brake system, right? When you talk about energy, to stop the vehicle, not about the vehicle energy. So either you can give through muscular drive pedal effort, or else you can have a brake boost system, which already I have explained, braking aspect, or else you can do the power brake systems, okay, or else you can have a surge brake or drop weight brake and spring brake. These are the 4 ways where you have to give your input for applying a brake. You could see that, right? So it's like a fulcrum method. If you give a small effort, that has to be magnified or energized. You could see this is called typical vacuum booster. So what happened? So you could see there is a opening valve is given like a kind of a diaphragm, right? So when you give a small movement, the air goes inside and give what happened, the big force. By giving that, you can activate your master cylinder, okay, with a small effort. That's why it's a booster, like enhancing the performance, right? This is the vacuum booster. Okay, and you could see again the same thing with this is we talking about the power brake aspect. So you have pedal to vacuum booster. From there you will move your, this is called a master cylinder. From master cylinder, this is the piston arrangement. The piston will try to move such a way that the brake fluid will pass it through the brake linings. Okay. Now we talk about energy transmission medium. So either you could have a mechanical brakes through rods, levers, cables and cams. You can see the rest, your handbrake system for braking aspect, parking braking aspect, hydraulic brakes, air brakes and electric brakes and the mixed brakes. These are the various type of energy transmission mediums aspect. And right, and this is the brake pedal design advantage. So normally it's like a lever method. If you give a small effort due to your lever method, right, like a momentum, right, so it will enhance the effort. That's one aspect. And this is another one is a hydraulic. So instead that you apply the by mechanical force pedal through here, then fluid will generate the pressure, right? The fluid will generate the pressure and try to activate through a caliper as well as drum brake system. This is happening through hydraulic brake system. Okay, and this is the information about the brake fluid. Generally, the brake fluid will have a following characteristics. Should have a correct viscosity all temperature. If the temperature changes, then the flow will affect. Okay, it should have high boiling point so that it should not catch with the fire, and should have non-corrosive and water tolerant, lubricates components, and the low freezing point. These are the typical characteristics you would expect for a brake fluid, and this classification is given .3, .4, .5. This is a typical brake fluids aspect. It's given by the Department Transport by US. They are the one who design them and define them, the brake fluids. Okay, this is a low viscous. .3 is the lowest boiling point, whereas .4 is the middle boiling point, and .5 is the highest boiling point. Okay, generally you can mix to enhance the performance between 3 and 4, but you can't mix at .5 because it's already highest boiling point. There is no reason for that. Okay, and this is for air brake system. Air brake system earlier used the mechanical movement, then hydraulic through pressure. Sometime instead of hydraulic you can have air brake system also. I am sure you would have understand whenever you travel for long distance, they will say our bus is fitted with the air brake system, because the execution of the power very smooth, so you don't feel much vibrations or shakes, right, due to braking aspect. And now we will talk about types of brake system. Okay, when talking about a brake system, how do you want to connect the brake fluid? Whether you want to diagonally split, this is the diagonal split, or else longitudinal split. Which is the preferred one? Diagonally split one is the best one. Okay, let me why I am saying that is the good one, this is the best one. Even due to some improper thing, you have assuming that you have a leakage here in this pipe, right? In this, if you have leakage, at least with the support of one front wheel, one rear wheel, I can able to balance the vehicle. Okay, assuming instead of that, if the leakage happen either rear or front, doesn't matter, what happened to my vehicle stability? It's not good, right? So it's a preferred to have a diagonally split arrangement for the braking aspect, right? So rear wheel drive, one piston from front brakes and one for rear. This is for rear wheel drive usually. Even if a leak occurs, you could lose front brakes, right? The front wheel drives vehicles, one piston drives front wheel and one rear wheel. Diagonally laid allows to maintain the directional control even if leak occurs. That's advantage having a diagonally split brake system. And yeah, that's what I asked the question, right? The braking ratio. When you give the braking effort, the entire energy won't go to front axle or rear axle. It has to split, right? So you can see that front brakes may handle to 60 to 70% of the braking. The rear is 30 to 40%. Why is less in the rear? When you apply a brake, some amount of weight of the vehicle is transferred to front axle, but you don't know how much. We will discuss as we move on. We will show exactly how much load is going to be transferred from rear axle to front axle while braking aspects. Okay, particularly we will discuss in the dynamic analysis. So obviously, so whenever you apply a brake, you have to have a more energy towards your front brake system than the rear brake. So front wheel drives usually will have a more weight is concentrated on the front wheels, a braking ratio even higher at the front wheels. Okay, and this is the types of friction brake. Drum brake, use brake shoe that are pushed out in radial direction against the brake drum. Okay, either you can have an internal drum expanding brakes, or else externally expanding. So what we have seen is externally, right, is externally expanding a brake system. Disc or brake used pads that are pressed actually against the rotor disc, and these are the images you can see that. So this is your disc brake and this is a drum brake. You can see this is the caliper arrangement, and you could see here. So tell me, this you can see this is the wheel cylinder, this is the shoe, brake shoe, and this is the return spring, and what you see here at the bottom is a duo system. You can see the self adjusting screw is given, okay, that is the one. And the non friction brakes, again we will have a engine a braking, exhaust brake, magnetic, which is types which are not going to focus now, right. This already we have seen the video where the caliper squeeze the pads to create a force on the surfaces of the rotor used in automobile application. It's very, the advantage is simple design, self adjusting caliper, rotor venting allows for a faster cooling aspect, okay. Look at the disc brake is very open, whereas a drum brake it has to be enclosed, so the heat dissipation will be difficult. And these are the single piston caliper assembly aspect. You could see that what is happening, this is piston arrangement you could see here, and this is the disc brake system, you can see slotted for a better heat dissipation. Sometime you may have, it's called a vent. Can you see that in the railway bogie disc brakes, this type of slotted vent is called, okay, slotted, so that heat dissipation will be much better. Of course, the Indian railway also slowly they are moving towards a disc brake system aspects, yeah. And now we will go for important thing before going about the design consideration. You have to think about the loading aspect when the vehicle is empty or fully loaded, both conditions we need to think about for designing the brake system. And also what is happening, static weight distribution for a lightly and fully laden. Laden means loaded aspect. And the more information you should know about the wheel base, this is dimension of your vehicle system, okay. And you should know center of gravity height for a lightly and a fully laden aspect. Intent function, when you talk about intent vehicle function means what purpose, is a passenger or cargo offload vehicle. Based on that your type of brake system also will change and reliability also will change. And tire and rim size, okay. Why I am saying the tire and rim size, will your brake system can be higher than the tire and rim? No. So we have to make sure that the disc brake or drum brake whatever you do should be lesser than the rim size. That is where the brake design will come into the picture, okay. And more important point, what is the maximum speed you are going to operate. So based on this I think there may be one more point will be there, that standard depends on the country. So based on these 8 points we are going to discuss the entire braking system design aspect over the coming lectures. I think I will stop now. Thank you.